Okay, hello folks. This is the video recording for the lab number 1, the morning class. And the problem is very simple. It's a single part. The dimensions are given here. The drawing is given there. And you are told that these holes, this hole and that hole, the inside surfaces are clamped. And that top face here is pushed down somehow. Entire face is pushed down by 1 millimeter. So every point on that top circular face is moved down by or pushed down by 1 millimeter. You're supposed to model this thing in CATIA, use as many planes of symmetry as are applicable, and use the most appropriate element. Finally, let's see now. Finally, what is the amount of force needed in order to create that deformation? Okay. Now, also you're asked to make sure that the mesh in the hole, around the hole, inside of the hole, is finer than the rest of the object. In other words, do local mesh refinement here. Now, the first thing that you have to answer is, how many planes of symmetry do we have here? Well, it is obvious that in this particular problem, there is only one plane of symmetry, and that is cutting it in this direction or in that direction, okay, along the length, like that, okay? Now, there are two ways to do this problem. One is to make half of this, because you know that you need to model only half of this piece in this direction. Model half of it, and then make sure that you use surface slider on the artificial surfaces that you have introduced. Or make the entire model and then split it with a plane that cuts this thing into two pieces. So it is crazy, because the way I'm going to do that, I will actually model half of it, but then I reflect it using the appropriate plane of symmetry so that you get the entire model, and then cut it again with that plane. I mean, this is crazy, but anyway, that's how I'm going to do that. All right. And my strategy for doing this problem is actually creating this rectangle here. You see that rectangle, this block here, this rectangle, and then pad it and do the rest of the problem based on the features that I see on this rectangle. Okay. All the dimensions are millimeters. Pay attention to that, and yep, that's pretty much it. So I'm going to go to CATIA here. And notice in class I said that we are not dealing with assemblies yet. We will. So my suggestion was, don't start in the assembly or the product. Okay. So close this. Start with a part file. That's entirely up to you, but make sure that if you're going to start with a product file, you can finish the problem, and you're on your own, basically. Okay. All right. So immediately I'm going to save this thing in a folder. So File, Save Management, Save As. I'm going to go to my desktop. Actually, I'm going to go to a folder here called Winter. What is that? Summer 2023. Okay, so I'm going to make a folder here. Call it Homework 1. Morning class, and say okay, and okay. All right. I just noticed something here. Let me show you something first of all. So one more time, File, Save Management. Notice down here, I have something called I've typed something down, and if I say apply the pattern, it will tag this thing on to the name of the file that I saved. So let me show you what happened here. Let me go down there in that folder, which I believe was okay. So let me go here, more up. I created this folder, homework one morning. I already saved this part in it, right? So if I go there and go to File Save Management and say apply this pattern, what that means is that put this after homework one morning. Let's check that folder and see what happened. This is the folder that I had. See this? Right there. You may find this thing useful, but anyway, it's something to note. All right. So I'm going to start with that rectangular cross section right there, which incidentally is, I believe, is 16 by 25 millimeter. But before I do that, let me go and change all my units. So tools, options. Okay, tools, options. Just bear with me for a second. Okay, so length is, we're going to use millimeters. And while we are at it, I'm going to use for pressure, which means kind of stress. Let's see if we can find it. I think in the new releases of CATIA, there is no distinction between pressure and stress, but here, this is an older version. So let me see if I can find the pressure here. Yeah, pressure. Actually, let me do the force too. Where is the force? If you want to put this thing in alphabetical order, click on the magnitude, and then it's alphabetical. So let's go force. I want to convert it to newtons. Newtons. Okay. And then pressure. Pressure. Do I have it here? Let me try stress. How about that? Okay. Actually, here's pressure. It's already in Pascal. And stress, let me check the stress if there is anything on the stress here. If not, this is going to be this is fine. This is going to be good enough. So that's good. All right. So on this vertical plane, I will sketch a rectangle of size 16 by 25. 16 by 25. So this is going to be 16 millimeters. Okay. And this is going to be 25 millimeters. 25. We say okay. That's that middle rectangle. I hope I didn't miss anything. 16 by 25. Yep. And then we're going to pad it by half the length, or actually I can do mirror extent. I'm going to do mirror extent by what is this length? This length, if you look at that drawing, that is 77, right? That length is 77. And I'm gonna do it. This is the view from the side. Yeah, this is 77. Half of that is going to be 38.5. So let's go here. So exit, padded by 38.5, but mirror extent. So that's going to be 38.5. Okay, now remember, whatever I do at the end, I'm going to cut it with that vertical plane, but that's okay. So the next thing I'm going to do is I will do this side face. You see this? So what I need to do on that face, I have to draw the rest of this. So let's do the following. let's go ahead and make a profile. So we go here. On that side face, I will sketch, and I use a profile to do that. So it's going to go something like that. And I notice that I'm not very fussy about making sure that these coincide, but we will eventually. Okay, so I'm going to draw something like that. Okay, a couple of things I want to do. I want to make this point on that line coincident to that line. So there are different ways of doing this, like this, control that. Oops, where's that? This point, control that, and you make it coincident. Okay, good. I want this line to be tangent to that line. So this line, control that. I want to make it tangent. Okay. Let's put some dimensions here. This dimension, this one is 80. Okay. This center to that line is 36, I believe. Yep. So this point to that line, 36. 36. Okay, and this radius is 18, or diameter is 36 also. So this diameter, radius is 18, or diameter is 36. 18. Okay, because I want to create a hole here, I might as well draw the hole right now. There are different ways of doing this. So if you find another way of doing it more efficient, please, by all means, go ahead and do that. So that the radius is 11. Okay, good. That's pretty much it on that side. So exit, okay, and then pad it. Yep, by a length inward, by a thickness. So look at the thickness. I believe that thickness is 10. So reverse direction, thickness of 10. Okay. Now, on this face, there is embossment. There is an embossment like that. It comes out, and the amount that it comes out is 6 millimeters. So what I'm going to do is the following. I'm going to go back here on that face. I will sketch. The easiest way to do that is to project the circle, for example. I don't know whether it's easiest, but anyway, right there. And I'm going to project that circle, or I can draw a circle here. Yeah, so let me draw a circle there. Where's the circle? Right there. And I'll make these coincident also. I think that radius, we put the appropriate radii here. So this one was radius 18. Okay, and this is of course projection. It is the correct radius. So exit and pad it. Okay, by 6 millimeter. 6 millimeter. There we are. Now this thing is repeated on the other side, so eventually I'm going to cut it so that there's only half of it. But for now, I want to create it on the other side. So look for the transformation features. There's a mirror here. Mirror. Now let me see. Now mirror. It's this path 2 and path 3 that I want to mirror, right? let's actually do mirror, let's actually mirror this. Yep, path 2 and path 3, but let's do it one at a time. Let's do path 2 first. This is the on that side. Okay, I also want to do this other path. So again, another mirror, this path with respect to that same plane on the other side. There we are. I mean, it is true that eventually I'm going to come back and cut this, you know, so that's crazy, because if you're cutting it, why do you project it on the other side or mirror it on the other side? That's right. So now we're going to do the bottom piece here. So this bottom piece, on the bottom piece, I'm going to sketch. Okay, so maybe what I can do, maybe what I should do is project this line, and then do the rest of it. So let's do a profile going from here to there, to there, there, and we're going to clean it up. Okay, so I noticed that I missed the opportunity to make this a curve, but that's okay because this thing that we need is here in the tools, right here. Let me put this thing up there. The tools toolbar right there. The opportunity is not lost. Okay, so we go here. Oops. Yeah, okay. Do it any way you want. Just get it done. Okay, a couple of mistakes here. I don't want this, so I'm going to delete that. I want this thing to be coincident with that. Just control that to be coincident. I did a couple of bad mistakes, but that's okay. We should be able to fix it. So this point to be on that, this center of the circle to be on that vertical line, this point, control that to be coincident with each other. Okay, and now we give it the proper dimensions. So the dimensions that we have to give, the distance from that center to there, I believe is 28. So the dimension from the center of this, okay, from the center of this to that, that should be 28. 28. Good. And the radius of that circle is, oh, this thing is 17 and a half. 17.5. Okay. And the radius of that circle is, let me see now. You look at this, 11. The radius of this is 11, or diameter is 22. Or you can make this thing 22, either way. Here, you go from here to here, 22. It is 22. You can see that. Good. Now, exit. All right. And then pad it by a height of 12. Oops, no, not 12. Height of, let me see for a second. We are looking at this. What is this? This thing is, yeah, that is 12. Oh, that's on the other side, on this side. Let me see. It must be, that information must be somewhere else. What is the stuff inside? So I guess this is the same as level as that. So that is 12. Yeah. Okay, fine. As a matter of fact, if that is the case, let me, yeah, okay. So let's, I'm making my job more complicated than it needs to be. A reverse direction, 12 inches, 12 millimeter. Okay. Now let me finish this. So I go to that face and I will sketch either there, or I can go to the bottom face. Yeah, I'll go to the bottom face and sketch. I'm going to sketch this piece for you. Okay, so something like this, profile from here. Actually, you know what? Why don't I make my job easier? I'm going to project that line. Good. And do the rest. Profile from here to there, to there, and to there. This last one I'll have to delete. Oh, Control Z. This one I have to delete. Okay, let's clean it up. This guy, control that guy to be tangent to each other. And this point to be on that axis. So this point control that axis to be coincident. Okay, good. And I think these are okay. Yeah, good, good, good. And there is a hole here. There is a hole at this side. Okay, so let's put the dimensions here. First of all, the radius of that hole is 9. So the radius of this hole is 9. Okay, the radius of this circle is 18. Yep, 18. Okay, and finally, the distance from that center to that line is 25. So the distance from this point to that line is 25. 25. Good. Exit. Okay. And we're going to pad it up. Reverse direction. Okay, you pad it up by 12. Okay, good. Now, on that face, there is another embossment, this thing, right? So the way I'm going to do that on that face, I will sketch. Why don't I project that circle? Okay, and I draw another circle here, concentric with this, same radius as this guy. Now, you know, there are different ways of fixing this. Like this, you can put a dimension here, or you can select this, control that, and you make them concentric. Oops, that's not what I meant. Control Z, Control Z. Concentric. Whoa. Something. Oh, consent. No, I'm sorry. Coincident. That's really what I meant. So let me Control Z. What I meant was coincident. This control that. Control this coincident. So let's try it again. This control that arc. Let's make it coincident. Yep. Good. Exit and pad it up by 4 millimeters. Pad it up by 4. 4. Just look at your drawing. That's what it is. There we are. Okay, why don't we save everything? First of all, this is all made out of steel. Why don't we add steel to it? Apply material, metal, steel on that part. Say okay, and save it. Good. Now comes the crazy thing. I'm going to split this. So use the split. Look for the saw with the look for this in the surface space feature. Click on the saw. Select that, and it doesn't matter which side we pick. I'll pick this side. There it is. So I did a lot of extra work for no good reason. but that's okay. All right, so save everything. And now we're going to go to generative structure analysis. CATIA immediately sees a solid part. It will mesh it. Fine, you can see the mesh. Right-click mesh visualization. There we are. Let me change the rendering here so that you can see the elements right there. Okay. Now deactivate the mesh because I want to get a finer mesh in this area. So let's say that, and here's the way we do it. Local mesh definement. See this in the model manager toolbar right there. Model manager toolbar, the one with the traffic light. You select on local mesh size. You go here, and already it puts an element of size. You can see that there was a default value 1.27. See, gigantic, a very small element. And this is just so that you can, let me make it a little bit bigger too. And now if you look at your mesh, where's the mesh? Right click, activate. There's going to be a finer mesh around the hole. Right there, you can see that. And let's actually do it on the other side. I also want to find a mesh in this area because that's what I've asked for. Same size, okay. And now if you look at the, if you activate your mesh, there we are. Finer mesh here, finer mesh there in that hole. Okay, so let's deactivate this. Good. Now, we're told that this surface is clamped. So clamp this surface. Okay, good. You can see the clamp sign right there. Yeah, it's clamped. And these are surface sliders. This is a surface slider, that's a surface slider, whatever is on plane of symmetry. Surface slider is right here in the, in the same place that you see your clamp right there. I moved it so you can see it better. Here you have surface slider. So this face and that face, and that's pretty much it. Say okay. Now, you are told that you're pushing this face down by 1 millimeter. In CATIA, if you want to push it down, or not down, if you want to push it by a non-zero value, obviously, first you have to make it a zero value. So I'm going to do this. I'm going to uncheck all of these so that we don't make a mistake. We know what's going on. On that face, no displacement in the direction Z. You might say, well, wait a minute, didn't you say you want to push it down by 1 millimeter? Yes, but first you have to make it zero, and then you go and change it. So look in the toolbar, the load toolbar right there. You can see that. Look, the third one from the right, it says enforce displacement. Enforce displacement means now force a non-zero displacement. You click on it. It says, well, what is it that you want to put an enforced displacement on that restraint? So you see that? We created a restraint. This last one was for pushing it down. So you select that either from the T or from the screen, and you push it down by 1 millimeter. Don't worry about this 25.4, whatever I did a few days ago, it still sits there, okay? But the point is that you want to push it down, which is actually -1, 1 millimeter, okay? All right, before we run it, by the way, before we run it, let me just show you something, one more thing. Notice that this is using parabolic element. I can use linear element or parabolic. Linear is faster, but less accurate. Parabolic is slower, but more accurate. So on a test, you will be told to use, unless otherwise stated, you will be asked to use linear element. Okay, so we say okay, good. File, save the analysis, save management. Here is the analysis, save as, in that same folder, which was called homework one morning. And notice that because I asked for apply the pattern, it's also added to the end of my oh no, it's not added there. So apply pattern right there. It applied the pattern. Yep, right there. Analysis one, Nader 972, etc. Say okay. And we're done. So let's run it. That's okay. This is the message saying that the rotation is not a degree of freedom, but you're using it. Well, I'm not using it, but anyway, rotation. Solid elements do not have rotational degrees of freedom. Now, if you want to see the deflection, you click on the deformation, and you can animate it. That will reveal any obvious mistakes. That's the way it should be, right? Push it down. If you want to see the numbers, you click on the translation. Or this one says this. This says displacement. Yeah, this was deformation. Yeah, and you double click on this. If you want average ISO, which means color contours, you do it. Change the rendering to material shading. You can see that. Anything that you don't like, you can hide. Okay, and as a matter of fact, if you want to see your elements also, you go to that rendering, go to the very last one, which says customize, and if you click on that edges, edges and points, which was already checked, it shows you the elements too. Now, anything that you don't like, you can hide. For example, all of these things you don't like, don't delete it. You can't delete it. You can hide it. You can see that. If you want to see the von Mises stress distribution, right there. Okay, good. These are the numbers. I think the yield strength for aluminum, for steel is 200 megapascal. No, yeah, 200 megapascal. So yeah, so anyway, just a reminder, roughly. Now, the other thing is that it says, what is the force needed to push this thing down? So what you need to do is you have to go to the sensor at the very, oops, where is this? Right click, create resultant sensor, reaction sensor. You click on the reaction sensor. You select that restraint either from the tree or from the screen. You see that? This is the one that you use to push it down. And then you say update. There we are. So it requires 30,000 Newton to push this thing down, but only half of it. So if on the test you were asked to find what is the force needed to create this deformation, what you need to do is you need to write this thing and multiply it by 2. Not half of it. You're going to lose marks if you just write this number, because this is the force for deformation that we model, which is half of the deformation. So it's going to be double of that, roughly 61,000. And make sure that you say, okay, you don't cancel it, because I need to see this thing when I'm marking your papers. I need to see where you got that number that you put on your paper. On your paper, you have to write double of this, but I have to find out where you got it from. And the only way for me to know is if you had said okay to that dialog box. If you had canceled it, maybe you saw the number, the correct number, and wrote it on your paper, but that's not good enough because I would not know where you got that number from. So that takes care of this problem.